For TI CC2640R2F Launchpad Hardware User's Guide, we will cover these topics: Hardware Overview, CC2640R2F Functional Block Diagram, Clocking, RF Front-End Configuration, Onboard PCB Antenna, and U.F.L. Backchannel UART through USB to PC, XDS110 Isolation Block P4, using an external debug probe to program the onboard CC2640R2F MCU, using the onboard XDS110 with a different target MCU, XDS110 USB Power 5 volts, 3 volt external power supply using P1, 5 volts external power supply using P2, measuring CC2640R2F Launchpad current consumption using DMM. Hardware Overview. Micro USB connector for 5 volts and debug, reset button, XDS110 debugger. It is a XDS110 based JTAG emulation for debugging and programming. XDS110 isolation headers, XDS110 out, and XDS110 in. Power select, switch 1 and switch 2 for user interactions, CC2640R2F 7x7mm package, Simple Link, wireless, and Bluetooth MCU. Booster pack connector, external flash, 24 MHz crystal and 32.768 kHz crystal, red and green LED, PCB antenna and optional U.FL connector, and mount for CC antenna decay. CC2640R2F functional block diagram. CC2640R2F provides complete solution for Bluetooth on a single chip. It has 3 cores. First core is the ARM Cortex-M3 main CPU. It runs your Bluetooth application. 128 KB of flash is available for your application code and stack. 8 KB of cache, 20 KB of RAM. Complete set of peripherals are available for your Bluetooth application needs, such as I2C, UART, GPIOs, and timers. The second core is the ARM Cortex-M0 radio processor, which controls the RF core. The ARM Cortex-M0 radio processor runs the radio firmware from RAM. The third core is the sensor controller engine. The sensor controller can run independently and offload processes from the ARM Cortex-M3. For example, when the main application is in running or in standby mode, the sensor controller can sample and average analog sensor data and then alert the main application for further processing. The sensor controller engine has specific peripherals that you can use, such as ADC, comparator, and I2C. Clocking. Y1 32.768 kHz external crystal. Bluetooth Low Energy requires a slow speed clock with better than ±500 ppm accuracy if the device is to enter any sleep mode while maintaining connection. There is an option to not use a external 32.768 kHz on your design to save PCB space, but instead use the internal low speed oscillator as reference. This is enabled through firmware. The 24 MHz crystal is required as frequency reference for the radio. The signal is doubled internally to create a 48 MHz clock. RF front-end configuration. From the CC2640R2F Launchpad schematic diagram, we are using differential output external bias, RF front-end configuration. RF front-end options. Based from the CC26XX hardware training RF front-ends and antennas document, the RF front-end options are differential output external bias, differential output internal bias, single-ended output external bias, and single-ended output internal bias. For the CC2640R2F Launchpad, we are using differential output external bias, and it has the best sensitivity, negative 97 dBm. RF front-end comparison. Differential output external bias overall is the best, with output power able to reach 5 dBm and BLE sensitivity negative 97, but it requires the most components, 5 inductors and 5 capacitors. For the CC2640R2F Launchpad, having this many components for RF front-end is okay. But if your product requirements need to be a small PCB footprint and coin cell operated, this is going to be a problem. So for a small PCB footprint and coin cell operated, it is recommended to use single-ended RF front-end configuration, which requires less components. Onboard PCB antenna and optional U.F.L. The default antenna is the onboard PCB antenna. Move the C51 to C58 position to select the U.F.L coaxial connector. The onboard PCB antenna is a 2.4 GHz inverted F PCB antenna. It can achieve 71% average efficiency, and the required space is 25.7 mm by 7.5 mm. Connections for U.F.L coaxial connector. U.F.L coaxial connector is for connecting the Launchpad to CC antenna DK antenna boards and also RF tester using a JSC to JSC cable, as shown in the screenshot. The Launchpad shown here is the CC1350 Launchpad. Backchannel UART through USB to PC. The XDS110 debug circuit provides a backchannel UART, which is very useful during debugging, especially when you are still in the prototyping stage of product development. The CC2640R2F SDK example programs uses this backchannel UART to print out at serial consoles, such as Teraterm or PuTTY. XDS110 isolation headers P4 connections are ground 5 volts 3V3 UART RX, UARTX, reset, JTAG TMS, JTAG TCK, JTAG TDI, JTAG TDO, and SWO. By removing the XDS110 isolation headers, you simulate the operation of a custom CC2640R2F board and power it externally. You can also use the XDS110 debugger to program debug other target MCUs. Using external debug probe to program onboard MCU. In this picture, I remove all jumpers at XDS110 isolation headers P4 and then connect a external XDS110 debugger using the XDS110 in connector of the Launchpad. Using onboard XDS110 with a different MCU. The XDS110 debugger is the Launchpad at the left, and the target MCU is the Launchpad at the right. Here, I am using the Launchpad onboard XDS110 to program a CC2640R2F TI reference design board. XDS110 USB Power 5 volts. The 5 volts is regulated to 3.3 volts for board operations and CC2640R2F. 3-volt external power supply using P1. Here, I'm using one CR2032 coin cell battery with 3-volt output to power the Launchpad. 5-volt external power supply using P2. Set P10 jumper to external power. Set jumper to P4 header, ground 5 volts and 3.3 volts. The 5 volts from P2 will be routed to the LDO, which will be regulated to 3.3 volts for board operations and CC2640R2F. Measuring the Launchpad current consumption using a digital multimeter. Connect the CC2640R2F Launchpad in series with the digital multimeter and set the dial to measure in milliampere or microampere.